Reflected intelligence model. It's almost like reinforcement learning for search with search feedback. But the general idea is someone comes to your platform, they run a search, they see some results. You log their search, you log the results that they see in the order that they see them in. You know what they clicked on, what they skipped over, what they purchased, what they added to cart, maybe what they removed. Like all of those are user behavioral signals. And there's many different types of models where we can take those signals, process them, and generate a relevance model that we can then plug back into the search system so that the next user who runs a search has a more relevant result because it's learned from those past user behaviors. And so some examples of reflected intelligence models are things like signals boosting, where somebody comes to your site and they search for iPad, and initially you're returning maybe like some iPad chargers or iPad like accessories because BM25 happened to match that, or maybe the semantic search did that. Well, once you start to see that people are clicking on specific items and products and purchasing those, well, guess what? Your users literally have told you what the right answer is. It makes no sense to do some sophisticated ranking process and benchmarks, who's on the MTEB leaderboard or whatever. Like what you should do is listen to your users and put the things up at the top that they're actually purchasing and clicking on. So signals boosting, we call that popularized relevance. It's really just a way of saying the things that are the most important for queries that users have implicitly told you, show those at the top. And that's for your head queries. You've got then things like collaborative filtering and matrix factorization for personalized search, where you're aggregating those behaviors to try to figure out for particular users or user groups, what do they care about, what are their interests. You've got things like learning to rank and automated learning to rank, where we're taking those user behaviors and automatically figuring out relevance judgments for particular queries and sets of results coming back. And then you can plug those relevance judgments into something like a learning to rank process that you can automatically learn what domain specific features matter in your domain. That's what we were talking about before for blowing away BM25. But you can learn those things not just by manually tweaking, but from automatically understanding and mining the user behavior. So that's the notion of reflected intelligence. And there's lots of other kinds of models as well. But the idea is you make your search engine, your retrieval engine, self-learning so that it's constantly improving with every user interaction. That's the idea.
Yeah, I guess just maybe like a quick thing, like how do you think about, it's like kind of obvious, like you have this like popularity signal and like how many clicks an object's getting. How do you think about putting that into your ranking expression and boosting like just like 2 times? Like, how do you think about designing that? Yeah.
Dude, Doug's our resident expert at learning to rank. I'll let him take that one.
Oh yeah, so that's a great question. So if you have a popularity signal, it's a tricky thing. If you're treating that as a feature in learning to rank, that's a really tricky thing because you have this echo chamber, right? You have this echo chamber of if something is popular and it's because it shows up in your results, and then you boost it higher because it's popular, you're just going to have people clicking on popular things. So that's a big problem. What you really want to do, so you can use it, and it's a really powerful feature in search. A lot of teams will even have a holdout where if they're using this kind of method, they'll have a holdout where they're not using the popularity metric from the from their learning to rank model or whatever that's using this. They'll actually use it more from a slice of user traffic that's not actually using sort of like getting this popularity treatment. So it's a bit less of an echo chamber. So there's that. The other thing is, and we talk about this, you can explicitly, there's a technique called active learning, where in active learning, your goal is to learn what's missing in the training data. So in learning to rank, you have a training data set, and the training data set is usually very biased towards things like historically, what have you shown in search? What has shown up a lot, like popular things. If you had like a strong title boost, for example, well, obviously the only things that are going to get clicked are things that are good title matches. So you look at your training data and you say, well, let me train a model that you can train a model to sort of like figure out what's missing. So this special class of models where if you give it a set of training data, like maybe a unpopular thing that's a strong body match or something, and this type of model will say, wow, my error for that observation is very high. And sometimes it can make a guess as to how, is this high upside with a lot of error? Is it and so possibly really relevant, but we don't know yet. And you can use that to say, I need to select for some of these results that are basically wide open gaping holes in my training data to try to break that echo chamber. So it's a tricky thing. Like a lot of search, especially head queries, do benefit from just, we see what users click on. If they like it, we show them those things that they're interacting with. But it also as long as you're aware of the challenges and sort of work to mitigate those challenges, it can be a really powerful thing to include.